Hello and welcome to the Bearded Math Man's YouTube channel. Hey, in this video, what we're going to do, I'm going to teach you how to solve trinomials that are in quadratic form, like this one right here. Let's get to it, shall we? We have two goals. I want to teach you how to solve these trinomials that are in quadratic form, either by factoring or by this new concept and application called substitution. Concept's not new, but the application is definitely new. So let's get into it, shall we? What we learned in the last lesson is that this is quadratic form because it's of the form ax to the power of n squared plus bx to the power of n plus c. So the last term's constant. This term right here, x squared, that's x to the 4th. So this is squared from here. So if you take this right here, x squared, and you square it, that's how you get your degree and your first term right there. So this is quadratic form. It's kind of like x squared minus 8x plus 24. Do you see? And so what we learned is that we can factor these, and we saw why this is true. And we also saw that a lot of the time when you factor these, there's more factoring to be done because this right here is a difference of cubes. So in the last video, this is what we learned how to do. If you're a little shaky on that or you didn't watch the last video, I'll put a link in the description. You can go back and you should go back and watch that now before continuing on with this, okay? So let's continue on. What we're going to do in this video is we're going to learn how to find the x-intercepts of this right here. They're often called roots, solutions, zeros, all the same thing. You set the equation equal to 0 and you solve it, right? So here we set it equal to 0. First step, we're going to factor it completely, which we've already done. Then we have to take each one of those factors, write an equation, and solve each one of these equations. So this one right here, when you solve it, you get an imaginary number, but the other two, we have -2 and +2. So really, not that difficult at all. So if it's factorable, and you know how to factor, you're good to go. Now, I think the most difficult part is actually getting from the original equation to the fully factored version, but that aside, if you're struggling with factoring, well, you just need to practice. That's really what it's going to take. But once you get that factoring down, getting these solutions down here is the easy part. All right, now, what if it's not factorable? Because that's when things go screwy, right? Well, this isn't quadratic. If it was, we could use a quadratic equation. We could use the quadratic formula for any quadratic equation. So what we're going to do is we're actually going to change this into something that is quadratic. Man, that seems kind of crazy, right? So let's talk about how this happened, right? So first thing we're going to do is we're going to say, well, I don't know what x to the 4th is. I don't know what x squared is, but I know this is of quadratic form. So I can actually make a substitution. I can say, well, let whatever letter I want, u be x squared. Well then, this is going to be u squared. And now I have something that's quadratic and it's simpler. So here's what's going to happen. Here's the overview, right? Even if you don't understand where this came from yet, how we got it, just stick with me. You'll see, okay? So here's our game plan. We can find out what u is because this is quadratic. And if we know what u is, then we can use this little equation right here that we wrote to figure out what x is. So suppose that we found, for example, that u is 4. It's not, but let's say it was, right? Well, we know u is equal to x squared, so that means that 4 is equal to x squared. So x would either be 2 or -2. This is an application of something that really famous, kind of obvious. It's called the transitive property. It says if a equals b and b equals c, well then a equals c. That's like saying if I have as much money as John, and John has as much money as you, well, that means that you must have the same amount of money as I do. Do you see? So if x squared is equal to u, right? So if u equals x squared and u equals 4, then x squared equals 4. If we know what x squared equals, we can find out what x is. Do you see? So we'll talk about breaking this down from this step to this step in the next slide. But let's go ahead and execute this game plan right here. Let's go ahead and use the quadratic formula to solve for u. What we're going to get is -2.208 and +1.208. Now what we know is that u equals -2.208. We also know that u equals x squared. That means that x squared must equal this. Do you see? X squared must equal this. So then I can take the square root and be done. Same right here. X squared equals this because u equals this and u equals x squared. So take the square root of both sides. Boom, we're done. And here, this one's imaginary. And I went ahead and graphed the equation, the original equation on Desmos. This is what we've got. This is a quartic. It's got a degree of 4, has 2 X-intercepts, one there, and we found them with this method called substitution. I know it's pretty confusing, right? Well, let's take a look at what's happening again, right? So let me approach this from a different angle. Here's what's happening. So we need to figure out what thing A is. We don't know what thing A is, but we do know that thing A is the same as thing B. But thing B we can figure out. And since we can figure out thing B, and we know that A is the same as B, we can figure out what A is. But we kind of have to go around a roundabout way of doing it. So let's see an example. Do you see this right here? X to the 6 minus 5x cubed minus 1. This is a trinomial in quadratic form because x to the 6 is x cubed squared. So this is something squared and then the something. Do you see? So it's not factorable though. It's not quadratic. So what we're going to do is we're going to do a substitution. We're going to say let's let u be equal to this thing, whatever this is. So u equals x cubed. Do you see? And do you see how x cubed is here and here? This is x cubed squared is x to the 6th. So we're going to let that be u. Now let's not lose track of our original equation. This is our original equation right here, x to the 6th minus 5x cubed minus 1. Do you see? Because we said u was x cubed, well, we put an x cubed right here, and we put an x cubed squared right here. Do you see? And now what we have is we have a quadratic. We have u squared minus 5u minus 1. And we could use a quadratic formula on that hotness right there, and this is what we get. Man, not too bad. Now, the tricky part is coming up with this let u equal x cubed part. The way you do that is if you have a trinomial that's in quadratic form, you let u equal whatever this was right here, because this one will be this squared every single time. That's how it works if it's in quadratic form. Okay, so now that we know what u is, we also know that u is equal to x cubed, right? Well, u is equal to 5.193 and u is equal to x cubed. So x cubed has to be equal to the same thing because u and x cubed are the same. So to figure out x, you just take the cube root and you're going to get 1.732. You're going to do the same thing over here, and you're going to get negative 5.77. So this is a tricky thing. This is kind of new. It's a weird application. I remember being a student trying to learn this for the first time. I had the most difficult part figuring out how to get from letting u equal x cubed to then, after I figured what u was, to how to figure out what x was. So that's why I use these beautiful blue boxes right here. Hey, there are some practice problems right here. You can find them on my website, thebeardedmathman.com. There also are typed up notes for this topic that might be a little bit easier to follow than a video, depending on how you prefer to learn. I'll put a link in the description below. Hey, if this has been helpful, give it a thumbs up. Go ahead and like it. Share it on social media. Leave me a comment. I would love to hear from you. Let me know how this is going for you, what else you'd like to learn about. Anyway, until next time, I hope you have a great day.